Hello and welcome to our next set of college algebra notes. We're on Unit 3, Outcome 4. So we spent the last two sections introducing exponential functions and then introducing their inverse, which are these logarithmic functions. In this section, we want to cover some of the properties that logs have. Logs have some pretty powerful properties. These properties are kind of related to how exponential functions work. Remember when you're working with powers, you can do things like two things with power. You multiply, you add the powers. You divide, you subtract the powers. If you have power to a power, you multiply. Those rules with exponents kind of turn into these three rules that we have for logs. So they're kind of a similar idea. So the first rule is called the product rule. The product rule says that if you have the log of a product, so two things are being multiplied together inside the log, you can actually rewrite this. You can break it up into the sum of two separate logs with the two different parts of the product. So here we have log of m and n. Now we have log of m plus log of n. So we can break that up. So maybe sometimes it might be harder to do the log of both things at once. So you can break it up into two separate logs, and that might make it easier. And so that's the product rule. The multiplication inside turns into addition between two separate logs. So for the example, this first problem here, we have log base 4 of 5 times 7. Since it's a multiplication, 5 times 7, we could break this up into two different logs. Notice that both of these logs will have the same base 4. The base on your logs doesn't change. The only time you ever change the base on a log is if you use the change of base formula we learned about last time, and we really won't use that. So there's not really any time you should change the base. You should almost always just leave the base. Again, if you have the old calculator, you might have to use change of base. That's really the only reason why you might use it. Otherwise, we'll just leave the base alone. So the base stays the same, and because we had a product inside, it turns into log base 4 of 5, log base 4 of 7, with a plus in between. So product inside turns into addition between the two separate logs. So we wrote it as a sum of logs instead of just a multiplication. So that's the product rule. Do the same thing here. We're going to break this log up into two product. Here you can see they have 12 and y. That whole thing is inside the log here. So that multiplication, 12 times y, can be broken into addition. So this becomes log base x, this is base x for this log, of 12 plus log base x of y. So again, we're breaking up that multiplication into addition. And so we broke that multiplication into a sum. So that's the product rule. The product rule, if you're multiplying inside a log, turns into adding between two logs. The next rule we have is called the quotient rule. The quotient rule just does this for division. So quotients or divisions, if you have a division in a log, you turn it into subtraction. Top thing goes first, bottom thing goes second. Subtraction, you gotta be careful because the order matters. If you mess up the order, you get the wrong answer. Addition's not, you gotta be so careful because if you switch around addition, it still works. When you're subtracting, you wanna make sure you put the first thing on top and the second thing on bottom. But that's what division does. Division inside turns into subtraction between the two parts. So here we have log base 3 of 7 over y. So we get log base 3 of 7, so log of the top part first, minus log base 3 of y. So log base 3, we get the log of the bottom part second. And that's our answer. We just wrote it as a difference, as a subtraction. Because division inside turns into subtraction between two separate logs. Let's do one more. So one more division here. Again, this one's log base x. So we get log base x for both parts. We know it's subtraction because we have 4 over 5. We have fraction. So we turn it into subtraction, and then we put the 4 on the first one and the 5 on the second one. So we get log base x of 4 minus log base x of 5. So we're breaking this up so we have less stuff inside the log. We just have more logs to deal with. But each one gets a part of it. So it breaks division into subtraction. Okay, there's one more rule. This is called the power rule. So these are the three big rules. We have product rule, quotient rule, and the power rule. The power rule says that if you have a log with a power inside, if you have a log with a power, then you can turn that into the product of the power times that log. So we took this power and basically pull it outside, put it out front. That's how this one works. So having log of something to a power, well, instead of doing that, you just pull the power and put it out front, and that gives you the same answer. So for example, we have log base 7 of 5 to the third. Well, the power rule, let's just turn this into 3 times log base 7 of 5. So now you just do log base of 7 of 5, get that answer, multiply that by 3, and you get the same answer as if you did this log right here. That's what this tells us. So the power rule lets us take the power and pull it out front. That's what the power rule does. Now one more here. This one looks weird because you look at this and you go, that doesn't have a power, that's a root. Remember, recall that those square root powers, those root powers, those roots are fraction powers. So when we have cube root of 6, that's the same thing as having 6 to the 1/3. So remember that the roots become fraction powers. So this is really just the same as doing log of 6 to the 1/3. Now that that's a power, we can just treat it like a power. So we can use the power rule, pull that out front. So that becomes 1/3 times log of 6. Now you might be wondering, where'd the log go? Remember, if there's no log written down, by default it's base 10, so common log. So this is log base 10 of 6. We just don't need to write the base down, because if you don't write a base, everybody knows you're assuming it's base 10. So you can leave off the base 10, but if you want to clarify, you could put that. But most people just write log, because they know that means base 10. Okay, so that's the power rule. Power rule lets us take the power and pull it out front, turn it into multiplication. We're multiplying 1/3 times that log instead of having the log of a power. Now, lots of times you'll take these rules and you'll combine them. So instead of just doing one rule, you might do multiples. We like to call this expanding logarithms. So we'll take and we'll expand a logarithm, because we'll break one logarithm into multiples, or we might pull a power out. And those will be all different ways we can expand a logarithm. The instructions for your homework will say rewrite as a sum or differences, but they really should just say expand, because they want you to expand as much as you can. So they want you to do all of these things. They want you to do any multiplication, turn that into addition, any division turns into subtraction, and any powers, they want you to pull those out. They want you to do all three. So something like this, we're going to do all three. Now you do have to be careful to do this in the right order. When you're expanding like this and breaking it up, you got to do order of operations backwards, because we're not solving this and we're not like finishing it. We're actually taking this and breaking it apart. So it's kind of doing the order of operations that we normally do when we solve something, but going the other way, because we're breaking this up, we're breaking it apart. So we're going to do the order of operations. Remember, you do your powers first, then you do your parentheses first, then your exponents, and then your multiplication, division, your addition, and subtraction. So you're going to think that order, but we're going to kind of work it backwards. So do order of operations backwards. So what that means for this problem is normally I would do my powers first and then I'd multiply. So to expand this, I'm actually going to undo the multiplication before I deal with the powers. So that's where it matters, because if someone tried to come in here and do the power stuff first, use the power rule first, it wouldn't work. You have to get rid of you have to break up the multiplication first. So this one becomes log base 3 of a plus, because this is multiplication, log base 3 of b to the 9th, plus, because that's another multiplication, log base 3 of c to the 4. So this is the product rule. And then once you have that, you can use the power rule and take those powers, like the 9 on the b and the 4 on the c, and you can pull those out front. So we get log base 3 of a. I'm going to leave the parentheses now that I only have one thing. You can kind of drop that. Over here we have 9 times log base 3 of b. I have one letter, I don't really need the parentheses. And 4 times log base 3 of c. So we pulled those powers out front. The powers got pulled out front, and we're just left with the, one thing inside each one. So we broke up the multiplication, we did the power rule, pulled the powers out, and now this is fully expanded. It's written as sums and differences. There's no differences in this one, but it's written as sums. But they also want you, again, like I said, pull the powers out. If you just stopped after the first step, this sums, they're going to say, that's not fully expanded, you should pull the powers out. So this is what they want. When they want you expanded out, that's what they're looking for. Let's try one more. Again, we got to think of the order of operations. So if I was going to do this problem, I'd look at this and I'd say, okay, normally you do powers first, you do the stuff on top, so you multiply here, stuff on bottom, you multiply here, and then the last thing you do is divide, right? Because of the big division bar, the last thing you do is you divide the top and the bottom. So to undo this, we're actually going to start with the quotient rule. That's going to be our first step. Because normally that's what I would do last if I was solving this. If I knew what the letters were, I would solve this. I'd do the division last. But since I'm breaking it up, I'm going to undo that first. So this becomes log base c of the top, which is a b to the fifth, minus, because remember division turns into subtraction. That's that quotient rule. Division inside turns into subtraction between two logs. Here I'd have log base c of the bottom, which is 2c to the third. Okay, so I broke it up into subtraction. Then I'm going to do the multiplication next. Again, you save powers for last because that would be the first thing normally I do. So when I undo multiplication and then I'll undo powers. So now I'll do the product rule. So I'm going to break this multiplication. So I got log base c of a plus log base c of b to the fifth minus log base c. I'm going to break this one up too, so that multiplication is going to turn to log base c of 2 plus log base c of c cubed. Now this is a place where a lot of people make mistakes. And, if you wrote it just like this, you're doing pretty good, but you actually did make a mistake. Notice that this whole thing is being subtracted. So when I split it into two pieces here, I need to show everybody that both pieces are being subtracted. If you don't do that, then you're going to get the wrong answer at the end. So you do need a parenthesis here to make sure everybody knows this subtraction applies to all the stuff here. You could distribute that minus, distribute to both parts, and then you could get rid of the parentheses if you want to. But if you leave it, that's fine. We're just trying to expand, so I'm okay with having a parentheses. That's not going to bother anybody. But you do need to make sure that you indicate that this minus applies to both parts. So if you type this in MATLAB without this parentheses, without distributing the negative, if you just had minus log this plus log that, you're going to get it wrong because it's supposed to be a minus for both parts. The last thing I want to do is the power rule. There's only 3 rules, so we know after this we'll be done. Here, the a doesn't have a power, so we're just going to leave it. We'll just call that log base c of a. We're done. There's nothing else we can do. b to the fifth, we can pull the 5 out front. So take this 5, we'll put it out front. We get plus 5 log base c of b. I got minus my parentheses. Here, there's nothing to pull out, so we're just going to leave it log base c of 2. And then the last thing here is pull the 3 out. So we can pull that 3 out here. We get 3 log base c of c. Now I show you something here. Notice this is log base c of c. These letters match. We've seen that before. We said that there's a rule for this. So the rule for this is that if the base and the number match, that cancels. The answer for that log has to be 1, right? Because you say, remember the log says, what power do I put on this base to get that answer? Well, the answer would be 1. In fact, you could have solved this one back here, because what power would you put on c to get c cubed? Well, the answer would be 3. So this one, you get 3 times 1, or just 3. Now, if you get a log like that, where you can solve it, I'm pretty sure MATLAB would want you to solve that. That's something you should be able to do easily. Now, if you're going to get a decimal, or if it's something you can't solve because like the letters don't match, then you just leave it alone. Like we can't do log base c of 2 because we don't know what c is. Previous one we had log base 3 of letters. We don't know what the letters are. So we'd have to leave those alone. But if you have something like this where the letters match, that one's pretty straightforward. We can solve that one. So we'd probably leave that as a 3. Over here we'd have to leave log base c of 2. Get your minus in the parentheses unless you turn this into both negatives. And then everything else, just bring that down. So if you can solve part, if the letters match like that, if the numbers match, then you can solve that part. But otherwise, we'll just leave it, not worry about solving it too much. Okay, that's what our answer would look like. Now, of course, with everything in mathematics, once mathematicians figure out how to do something one way, they always got to turn around and say, can I do the same thing backwards? Instead of expanding a logarithm, can I take a bunch of different logarithms with the same base and put them back together and get a single logarithm? And the answer is yes. So instead of expanding, you can actually condense. So that's our next step. Our next step is to condense logarithms. So now we're going to condense. So we're going the other direction. We want to condense. The first one's pretty straightforward. There's only one thing to do. Here they have minus. So that minus between two logs, we could go around, turn around, go the other direction, and turn that into a division between two logs. Inside a log, sorry, inside a log. So instead of having subtraction between these two logs, we get one log, one big log, I'll put a big log here, with a division in it. Remember that the first number goes on top, so this 2x is going to go on top, and then the second part, goes on bottom. So this 5 goes on bottom. So subtraction between two logs can be condensed. It can be, put back together as a single logarithm with a division, because that subtraction turns back into division. So these ones are going to want you to go to single logarithm. You should always be able to condense things down so that you only have one log when you're done. If you still have two logs, you are not done. That's why you're going to say single logarithm. Of course, the rule is that the logs do have to have the same bases. So you saw these have base 3s. Next problem will have log base 2. That does have to be true. The bases all have to match. I'm not going to give you any problems where the bases don't match. That's beyond this class. We'll leave that for more advanced math courses, something where you might see that. But for our course, it'll give you a problem with all the same kind of logs, all the same base, and you should know how to condense it using those three rules, using the product rule, the quotient rule, the power rule. Again, we're just using these backwards. So the subtraction between two logs, the quotient rule, we're going to take that back into a quotient or make it back into division. If I have an addition between two logs, we're going to turn that back into a product. But we also have here, you notice there's the numbers being multiplied times each log. Those numbers being multiplied are power rules. So we actually have both. We have a power rule and a product rule in this next one. We got to figure out which one to do first. So now we're condensing, we're not expanding. So the trick is the rule for condensing is go back to the order of operations, but now we're going to do it the right ways. We're not going to do it backwards. We're going to do it the way you normally do. So now we're going to do the order of operations. Do that order of operations right ways. So if I look at this, what would I do first? Well, normally I'd multiply before I add, right? Because multiplication and division always come before addition and subtraction. So to do this one, we're going to do the power rule first. Because remember, when you have something on the outside like this is because of the power rule. So we're actually going to put it back inside of the power. So something like this 2 log base 2 of r, we're going to actually put that back together and get log base 2 of r squared. So we're putting that 2 out front back in as a power. Next one has a 1/4 in front, so this can become excuse me, log base 2 of s to the 1/4. So those multiplications out front go back in as powers. That's how we get this. Addition, remember, that's product rule. We're going back to multiplication. So when you have an addition between two, it's going to turn back into multiplication inside one. We have 1 log base 2, just one of them, but this time we're going to have the r squared and the s to the 1/4 inside that log. Now it looks pretty good, but this is actually one you'd still get wrong in MATLAB if you put that in like that, because they're going to say no one wants you to give them fraction powers. So if you end up with a fraction power, remember, note that s to the 1/4 is the same thing as the 4th root of s. We always prefer those roots if we can work with them. We just end up having to, sometimes, work with the powers when we need to work with the power specifically, do things like pull it out. But if you end up with a fraction power, you should always kind of try and take it back into a root. So the best answer for this one, the one that MATLAB would definitely accept, the one I'll look for in the exam, is going to be this, where you have r squared and then you're going to have 4th root of s. And that's going to be your final answer. That's what is going to get accepted and get full credit on the exam. So if you have a fraction power, remember to always turn it back into a root so you get full credit. Okay. Do I have more practice? I think I might have more practice of this. Yep, one more. Let's do one more. So this one, again, tells us to go back to a single logarithm. So we are condensing. And again, we've got to think of order of operations. So first thing I see is I got multiplication, addition, subtraction. You always start multiplying before you add, subtract. So we're going to do the power rule first. We'll take that 2, put it back into the power. Take that 3, put it back into the power. Take that 7. Back into the power. Just putting the powers back in. So I get log base 5 of x squared plus log base 5 y cubed minus log base 5 x to the 7th. So I put those powers back in. Now that I got the powers back in, now I'm going to go ahead and do my addition and subtraction. I got to figure out which one to do first, but remember the rule is for addition and subtraction, you do whichever one comes on the left. That's what you do first. It's not subtraction second, addition first, or vice versa. It's both at the same time, addition and subtraction, and just start from the left and work your way right. So I'm going to do the addition first. I'm going to do the product rule first because it's the one that's on the left. Something to remember about those PEMDAs is addition and subtraction happen at the same time. You just work left to right. So we'll do this one first, Addition, this turns back into a product, so we get log base 5 x squared y cubed, because that addition turns into multiplication. Still minus log base 5 x to the 7th. This subtraction turns back into division, so I get log base 5 of division, x squared y cubed goes on top, and then x to the 7th goes on bottom. Again, always the top is the first part, and the bottom is the second part. Subtraction turns back into division. That is our final answer. Again, all these are nice powers. Oh, whoops. This is one, oh, I don't remember for sure. This is one of those problems where I'm like, oh, I don't remember exactly how they wanted you to answer this on the homework. So just a heads up on this one, because this might happen to you, is note that these x's here, those are both x's. And you could actually simplify this. So this one, I'm guessing my math lab will actually want you to simplify. I wouldn't give you one like this on the test, because I think it's kind of unfair, because you're already doing all the work of combining it. I won't make you do this. But if you ever see something like this on the homework is going to want you to simplify. They're going to want you to look at that and say, oh, look, I've got x squared on top, I've got x to the 7th on the bottom. Those are matching x's, so we can simplify. We can use that power rule that says if you divide things with powers, you can subtract the powers. So subtract the powers. So we take 7 minus 2, and we see we get x to the 5th. So the real final answer, the one that's simplified, again, I would not do this on the test. This is something I think I saw in the homework, so that's why I put it in here. Kind of forgot about that. This one, for the final answer, you want x to the 5th, y to the 3rd. Because you take, oh, I made a mistake. 2 minus 5 is, 7 minus 2 is backwards. It's 2 minus 7. Negative 5. Negative 5, which we don't want a negative power, so I should move it to the bottom. Yeah, sorry about that. I totally spaced that part. Again, something I wouldn't really put on the test. That's why I forgot that they did in the homework. But I wanted to help you out with this. So if you do see something like that where they have the same letter, remember that you can simplify those. It's always top minus bottom. I had it backwards for some reason. My brain was backwards. So I'd get negative 5, and we don't like negative powers, so this actually becomes y to the 3rd on top, and then to make this positive, we put the x to the 5th on the bottom. Another way to think about it is you could think about canceling 2 of these x's. There's 2 on top and 7 on bottom, so you have the 5 on the bottom. And that would be the preferred final answer. This is, right for my lab. Again, I would not do this to you on the test. I'll have you combine stuff, but I'm not going to have you combine and then have to simplify at the end. So I'll give you a problem where you just be done here, because this will be like a z instead of an x. That's what I do on the homework, on the test. But on the homework, there is somewhere you have to actually simplify a little bit before you get the final answer. Okay, there's one more property they want to talk about, and this is actually going back to something I mentioned at the beginning of the set of notes. Remember that logarithms, we discovered logarithms, we started using logarithms because they are the inverse, the opposite of exponential functions. So remember those exponential functions that look like that, b to the x? Those guys are opposite of log functions, log base b. They're inverses. And inverse functions are opposites, which means if you do both, they cancel. It's like when you add some money and then subtract the same amount. Add $5, subtract $5. Or if you double something and then divide by 2, those are opposite functions. They're things that cancel each other out. Well, b to the x, which is the exponential function, b to the x, the exponential function, and log base b of x, the log function, those are inverse functions. They're opposites. So if you do both, if you combine them, they do cancel. So that means that if you have an expression like this, we have log base b of b dx, and this is where you take the b to the x part and you plug it in here. You replace the x with b to the x. That's what happens here. Well, then the log base b and the b cancel, and you're just left with the x. You're just left with the power. Vice versa, if you take this log function, you put it in the power, so you get b to the log base b of x. Those are inverse functions, and they do just cancel, and you just get the x. That means with an expression like this, we have 12 to a power. That's going to be your b to the x. So b to the x in this case would be 12 to an x. And you have a log base 12 of something. So that's going to be your log base b of x. In this case would be log base 12 of x. You can see how we're just putting that 12 in there for the base. But the bases match. The bases both match. They're both 12. If you combine a b exponential and a log, if you put them together like that, then they do cancel. Inverses cancel. Which means that this one's really easy. Once you cancel these, the answer is just 5 minus x. That is the answer, because everything else is canceled. So they want to find the value without using a calculator. Well, we can't find the final answer because we don't know what x is. But the big idea is to try and get the answer and get rid of all this other stuff. So here we can see that the final value is going to be 5 minus x, whatever x ends up being. Next one's kind of similar. This one, again, they threw that root in there. So just note, recall, you guys should remember by this point that the fourth root of 7 can always be rewritten as 7 to the 1/4. We'd much rather work with powers right now because a power is going to be an exponential function. So we can actually write this as log base 7 of 7 to the 1/4. And then you can see how this is log base 7. So the log base b of 7 to the 1/4, which is the b to the x. So the b to the x would be the 7 to the 1/4, and the log base b of x is the log base 7 of x. Not b to the x, I guess. Oh, I should put that as an x. X in this case is going to be the 1/4 because that's working with power. So this one, the log base b, the log base 7, and the 7 base, that all cancels. We're just left with 1/4. 1/4 is the answer. So again, it has to do with the log base 7, this log function, and the base 7 to a power, 7 to the x. Those guys are inverse functions, so this cancels. So whenever you see a log and then something to a power like this where the bases match, you can cancel everything except for that power. When you see a base and a log with the same base, base to the power with log same base, and those cancel, and you just get that power. So that's going, again, that's going from the inverses, the fact that these logs are inverses. And so it gives you sometimes equations that are really easy to solve, even though they look weird to start with. You can get an equation like this, and it looks, oh, this looks crazy because there's logs and bases. But notice that this is 6 to the x and log base 6 of x. And they are inverses. They are opposites. 6 to a power, log base 6. Those are inverses. They cancel. So we can just cross those out. And so this side just becomes 15 because that 6 and the log base 6 cancel. We'll use this fact next set of notes. Next set of notes, we're getting more into solving logarithm equations and equations with x's and the powers and stuff. And we'll see that that's one of the big things is you'll end up with stuff with powers and logs and combine it to be able to solve using this inverse property. Let's go ahead and finish this one here. I'm going to divide by both sides by 3. So just working to get x by itself. 15 divided by 3 is 5. And so we see that the answer here is 5. You could check it. You can put 5 and you get 15. And again, this solves and gives you 15 on this side. So 5 is the answer on this one. So that's it for this section. The big thing really here is knowing the product quotient and the power rule. And honestly, the way we use it the most after this section is the break apart method. So there are going to be some equations next set of notes where we will take them and not break apart, combine. The condensing method. We'll take some logs and we'll condense. That's probably the primary way we'll use it in the future. But that's it. That is it for outcome 4. It's all about those product quotient and power rules, and then the fact that logs are inverses with exponential functions. They do cancel each other. I will see you on the next set.